Mirrors in space, a brand new monkey, deep space sugars, and salty batteries. That's what's been going on this week in science and technology. Mirrors in space reflecting the sun onto parts of the Earth that would otherwise be in darkness. That's the idea of Reflect Orbital, a company based in California. And companies always have these wild ideas, but this one has been approved by the FCC to put an 18-meter mirror in orbit. This isn't a new idea. In the 90s, Russia launched a series of experiments called Znamya, one of which was a 20-meter wide reflecting mirror that would reflect the sun's light onto a about 5-kilometer wide bright spot, about as bright as a full moon. Reflect Orbital say that there are a bunch of good reasons to do this. For example, they could assist with search and rescue operations, they could allow construction to take place round the clock, they could charge solar power banks overnight, or at least after the sun's supposed to have gone down, and they could increase crop yield. But what they don't suggest as a good reason is probably their favourite reason, that you could charge an awful lot of money. They're not going to be doing this for free. But critics argue that this is a terrible idea because it's basically just light pollution turned up to 11, and light pollution already can and does interfere with the circadian rhythms of animals, including humans. Growing crops with more hours of sunlight than they would expect at that time of year is something that we already do indoors hydroponically, but taking that outside and scaling it up is such a huge change of scale that the difference in amount becomes a difference in kind. The satellite constellation Starlink is already causing problems for astronomical observations from Earth, and they're not even trying to reflect light to Earth, and they've got about 10,000 satellites orbiting the Earth. Reflect Orbital want to aim for about 50,000. You may have guessed this already, but in my opinion, it's a pretty crap idea, because all of the situations where they've said it might be useful would be better served by something that already exists. So for search and rescue, you'd be better off using floodlights or perhaps a helicopter with a searchlight on it. That's why it's called a searchlight. And for growing crops in challenging conditions, you'd be better off growing them indoors under a grow lamp, which we already do. And as for charging solar panels at night, you'd be better off just building more solar panels and then storing the energy that they generate in a battery pack overnight so that you can use it at night. None of the existing options require burning a ton of rocket fuel to create more space junk, and none of the existing options require it to be a cloudless night. Your mileage may vary, but I live in the UK and a cloudless night is a pretty rare thing. Lastly, I think this would be a step towards something that we've probably all considered but not considered very seriously, and that is the prospect of somebody using this for advertising. An array of orbital mirrors could be bright enough and legible enough that you could communicate to someone, hey, I know you're sat there just enjoying the night sky, but maybe buy this product. Ew. Light pollution, capitalism edition. Also, new monkey just dropped. That's right, an entirely new species of monkey was found in Congo's rainforest. They are adorable, with pinky orange lips and a little bit just underneath the nose. By the way, did you know that this groove under your nose has a name? It's called the philtrum, and monkeys don't actually have one, but what these do have is an adorable splash of orange colour and cheekbones for days. Their species name is Colobus congoensis, but the people who live in the area call it Liqueli or Cassaba inconi, which means the branch shaker, and people who live there probably don't see them all that often because they tend to live quite high up in closed canopy rainforests. And it's not that people never see them, but over the past 20 years there have been only 114 verified sightings, but that's enough to confirm that it's a previously undiscovered species. In addition to having a unique look, they also have a distinct roaring call. Researchers hope that now the species has been identified, it can be legally protected. New discoveries are always being made in space, but they're very rarely delicious. That's not the case with the discovery of sugar in deep space. Scientists have found ethrulose, a kind of sugar that you've probably eaten if you've ever eaten red raspberries. Before we get to that, did you know that red raspberries, blackberries, and black raspberries are all different species? They're all members of the Rubus genus, but they're different species. I didn't know that. Anyway, red raspberries contain etherallose, a sugar, and that same sugar was found in deep space using radio telescopes, the IRAM-30M and the Yebes 40M respectively, pointed at a molecular cloud in deep space near the centre of our galaxy. They identified the molecule by comparing the signature that they detected to a similar signature acquired on Earth in a lab, and this is really significant because sugars are such important molecules to life. This doesn't mean that what they found is an indicator of life, not least because it was found in the cold, dark vacuum of space. But one of the big origin of life on Earth questions that we have is how simple sugars formed on early Earth, because lab experiments that have attempted to recreate the conditions of life on early Earth have not managed to result in simple sugars yet. It's estimated that between 500,000 and 50 million tons of this sugar could have arrived at Earth during the late heavy bombardment, a hypothesized period of Earth's history and the solar system's history where planets in the solar system were subjected to a massive spike in the arrival of asteroids and comets, and so it's possible that some of the sugars that life now depends on were seeded from space, but don't quote me on that. In one way or another, the world runs on electricity, which is why it's so useful to have a tube of it that you can carry around, and as a result, batteries are in very high demand, and the most popular chemistry for those batteries is lithium ion. There's also lithium polymer, which is probably what's powering the device that you're using to subscribe to this channel right now. But there are many problems with the lithium they use. For a start, lithium is extremely toxic. The mining process can leach chemicals into the environment, and it costs an awful lot of CO2 to extract it. So for a long time there's been a push to see if there's another way to do this, something that could replace lithium in batteries. Enter sodium ion batteries, which were being developed around the same time as lithium ion batteries, but because lithium ion showed more commercial promise, sodium ion was put on the back burner. But it's back now. On Earth, sodium is about 1,000 times more abundant than lithium, and the process of mining it and refining it is much less damaging to the environment. So, CATL, the world's biggest battery manufacturer, is putting sodium-ion batteries into production. It's a technology that's finally leaving the lab. So a company called Alfen, based in the Netherlands, are working with CATL, based in China, to deploy about 5 gigawatt hours worth of sodium battery storage systems all over Europe. And that's a really good way of getting them out in the real world, helping out and actually doing their job in a way that is away from everyone else, just in case something goes wrong. It's much better than, for example, an electric car, which could be in a crash, it could be in a really hot or a really cold environment, and you have a lot less control over what could happen to it. But in an installation like this, it means that those things are just away from everyone else and they can get some time in actual use. The hope is that eventually sodium-ion batteries will replace lithium-ion batteries, but we'll probably have to wait a little while for the technology to mature, because currently sodium-ion batteries are not quite as energy dense as lithium-ion. How much depends on who you ask, but a common estimate is about 30% less. Their lower power density means that it's unlikely that sodium-ion batteries are going to replace the lithium-ion battery in your phone or tablet or car. But even if they become the standard battery for the storage of power that doesn't move, like storing solar power overnight, that's still less demand for lithium. And on top of that, every time someone buys a battery, you justify more R&D into bettering that particular chemistry of battery. So those are the science and technology stories that grabbed my attention this week. What did you think? Did I miss any? If I did, let me know in the comments and maybe I'll cover them next week. Thank you very much for watching. Don't forget to leave a like on the video and subscribe so you don't miss the next one. See you next week.